Part of that is just going over our warm-up. On Friday, we talked about extreme values of our functions, which would be our maxes and mins. If you read the directions carefully on this one, it only asked us to find the absolute. We learned about that there's two different types, like absolute and relative or local. And so if we're looking for an absolute extrema, it would have to be the highest point or the lowest point in our entire graph to answer that. And then the thing that people miss on something like this is that it asks you for both the x and the y value when it asks you for what is the value and where is that value. The what is your y value, the where is your x value. So looking at this first one, you should have had one extrema. It does have an absolute max. And again, we learned how to format our answer. Identifying what we're looking at, absolute max, identifying the value of it, which would be your y value, so an absolute max of 5, that's the highest value in this graph, and the location of it would be your x value, so that would be at x equals 3. We talked about that, yes, it looks like it's got a minimum, but because that's an open dot, it does not include that. It's not included on our domain. And so we can't say that that's a minimum, and actually continues to get closer and closer and closer to that forever. So there's no like value right above that that we could call the minimum. So any open dot is not included as an extrema. Same thing happens on the next one. We do have an absolute maximum happening here. So we would say absolute max. Again, of a value of, and that would be your y value, at x equals, and the x value of that coordinate, which would be -3. As far as other extrema in this one, very similarly on the minimum, because it's an open dot at the bottom of that parabola, not included. So this does not have a minimum value. If we were to take out the word absolute in the directions and just say, find your extrema, it would have a local max or a relative max right here. Of 0 at x equals 2, but it did just ask us for the absolute, so we would not have to identify that one. Questions on that? Not much to add today to what we talked about on Friday. Just a couple things that are going to show up like on your assignment that we might need a little bit of conversation about before we get going. And the first of those is just remembering how we attack a derivative if our function is an absolute value function. So I'm going to give you guys some time here at the beginning to talk to your tables about this. If I told you it was an absolute value of x minus 5, there was a little trick to it when we were trying to find our derivative. So if you guys can remember what it was we did to attack this function. Okay, did any table remember what we had to do before we started taking the derivative of this? Yeah, break it into our piecewise function. Now we got to remember, how do I write this as a piecewise function, right? We talked about the two different pieces are going to look like, so remember what this is, absolute value, a V graph, one of those has a negative slope, one of them has a positive slope. Rewriting this as a piecewise function, it is that equation right there. One of the sides will just be that equation, and that's on the positive side of your graph. The other one will be the opposite of that, and the way we show that is the negative x minus 5, and figuring out where that's located. And guys, there's a lot of ways to attack this. It's basically figuring out where the vertex is. Where does it change from having a negative slope to having a positive slope? And you can kind of go about it a couple different ways, setting what's in there equal to 0, remembering your transformations, trying out different values to see when that happens. But this is a absolute value of V, that is, do we remember our transformations? Where does that move it? Right 5. Okay, so it's going to move my graph to the right 5, and that might help you with your domain on this one, because that's the negative slope. That's this one right here, and you can see that would be for all x's less than 5, right? And then when x gets bigger than 5, or including 5, we would use the positive slope of that equation. It doesn't matter which one you make equal 5, but at some point it is continuous, right? It's got a value at 5, so one of those has to say or equal to. It's going to be 0 for both of them, so it doesn't matter. But you do have to break it into the two pieces before we go to the derivative part of it. Now, for the derivative part of it, I would probably rewrite that second one, distribute that negative through as negative x plus 5. Okay. Question so far? Okay, so I haven't done anything. I just rewrote it instead of writing it as an absolute value symbol as its definition using the piecewise. The question was find the derivative. Well, the derivative is going to be of each part of that. And again, kind of a couple different ways we could look at this, but if we just looked at the equations themselves, the derivative of the first one, again, power rule, 1 times 1 is 1. Subtract 1 from our exponent, we would just have 1. Derivative of negative 5 is 0, right? And of that second one, same idea, but it'd be negative 1. And that first one is when x is, and watch what I change here, greater than 5. And the second one is x is less than 5. Guys, why did I change that? Why did I not leave the or equal to in there? You know? It's not differentiable, right? Yeah, it's not differentiable at a corner. Right? So I can't have my derivative defined at 5. There is no derivative at 5 because the two sides of it are not the same. It fails to be differentiable at any corner, cusp, discontinuity, vertical tangent. Remember all those rules for where it fails to be differentiable. So that's why I have to change this to not or equal to. Any questions on that part? Okay. One of the other topics that we keep bringing up to review is the idea of our unit circle. Now, this is kind of a challenging question, so I'm going to help you by saying think unit circle, but I want you to solve this equation for x. Think about your unit circle and talk to your table about it. It's not an obvious answer. Might be easier if you move them to opposite sides of the equation. Maybe. Kind of. Coming up with anything over here? Good, good. It's one step. Any ideas over here? Nothing yet? What? Do we have another hint? X is an angle. Is that it? I know. X is an angle. I like that. Here's a good hint over here. We have a good idea. It has to be in quadrant 2 or 4. Maybe discuss that. That's why we're doing it together. Lots of brains. One question. Okay. Are we ready to like bring all of our ideas together here? I suggested maybe moving them to opposite sides, and the only reason I did that is to maybe get to the fact that it needed to be quadrants 2 and 4. So, Caitlin, we're going to come back to your comment here in just a second. If I were to move them to opposite signs, why did you decide it has to be quadrants 2 and 4? Yep, they are opposite signs in quadrants 2 and 4, right? So right now they're saying that they are equal to each other except for they are opposite signs. And that would happen, or could happen, in quadrants 2 and 4. And those that, and this is not going to look familiar to everybody, but some of you have been introduced to All Students Take Calc, just a little mnemonic device to remind you where things are positive and negative. All things positive in quadrant 1, right? Sine only, tangent only, cosine only. That means that sine's positive here, so cosine's negative. Opposite signs in quadrant 2. Cosine's the only thing positive here, which means sine's negative. Opposite signs in quadrant 4. So I know my answers are coming from quadrants 2 and 4. Now, what type of an angle then gives me the same answer for cosine as it does for sine? Pi over 4. If I do sine of pi over 4 and I do cosine of pi over 4, we get square root of 2 over 2. But I want a pi over 4 in quadrant 2. What is the pi over 4 in quadrant 2? 3 pi over 4. What is the pi over 4 in quadrant 4? 7 pi over 4, or negative pi over 4. Okay. Again, something that's going to show up in one of your problems today, and I wanted us to kind of help each other through that, because I know we all understand what just happened there, but at the beginning it was kind of like, I don't even know where to start this problem, right? But think through that unit circle idea there, where they're equal to each other, opposite signs, etc. All right, and this page just kind of recaps what we talked about on Friday. On Friday, we talked about our extreme value theorem. And that extreme value theorem said that we had maxes and mins guaranteed if it was a continuous function on a closed interval. To find those extreme values, we made a list of points, and those list of points came from these things. The endpoints of a closed interval, right? We don't test out numbers if it's on an open interval, but if they're endpoints of a closed interval, we put those numbers into a table of values. We included anywhere that our derivative was equal to 0, if that were to happen. We included anywhere that our derivative was undefined, if that were to happen. And we talked about a lot of values where a derivative might be undefined. A lot of times that was like if it was a fraction and we could set the denominator equal to 0. But that could also happen at like the corner of an absolute value graph, right? Because your derivative is undefined at the corner or cusp or discontinuity of a function. I did put this on here as well just to kind of help you on your assignment, because everything we've done up till now has been finding maxes and mins of a function, an f of x. But we can use these same concepts to find the max or min of any function. So maybe they ask you to find the extrema of your velocity function. Well, if we're trying to find the maxes and mins of our velocity function, that kind of adjusts this a little bit, because then we would use the zeros of your acceleration and the undefined points of your acceleration, the derivative of whatever function they're asking you to find the max and mins of. So kind of adjusting it to the question itself. Any questions for me? All right. Your assignment then is a worksheet today.